Hi, this is Kristen. This is page 1 of exam 2B key, um, starting with the fourth problem on the first page. So on the fourth problem, here we have an alkyne triple bond reacting with H2SO4, H2SO4, and water. When this reacts, this adds water across the double bond in a Markovnikov fashion. So we would be adding H and OH in a Markovnikov fashion. And then that would tautomerize to the ketone. So this is testing that you know how the tautomerization happens. So when I have this reaction happen, the difference here is I have like a secondary carbon here and a secondary carbon in this spot. So once I form the enol in each case, I can't tell which one's better, which one's going to have the Markovnikov product. What really happens is that I get a mixture of both because they're both equally likely to happen. So I will both get this ketone where the O adds to this carbon, as well as the ketone where it has added to the other side, both of those. Because again, even though I do expect more Markovnikov product, there's no difference between those two carbocations and the intermediate. So I would get both of those products. Those aren't stereoisomers, but two separate problems. So there's that one. On the next question, make sure I get centered here. Is that once I react this under these conditions, what product do I get? And so here I have an alkyne. When I have an alkyne reacted with sodium and ammonia, notice this was sodium 0, the metal, and emphasizing that it's the metal. This will then reduce this reaction, so this is a reduction. And it reduces it in a way that would give me trans double bond. So that's something I would have to remember. In this case, it doesn't matter though, but it is key that I do not reduce it all the way to the single bond, only to the double bond. So when I have my product, I keep all 1, 2, 3, 4, 5 carbons. I have all 5 carbons, and I have a double bond at the end. Okay? And that is neither cis nor trans. Important though that I still have a double bond. So this one was a reduction, and then because this number 2 here asks you to identify an oxidation, reduction, and a neither, I'm going through those as well. This one up here is neither because what I've net added, so if you count the atoms here, I have C 1, 2, 3, 4, 5, 6, H 1, 2, 3, 4, 5, 6, 7, 8 over here, and then both of these have the formula C6 H10O. So I'm adding an O and 2 H's to each of these. So it's like I'm both reducing and oxidizing. So that makes this a neither reduction or oxidation. Down here, the very last question, I have a primary alcohol. I have chromium oxidizing conditions here. And so this, in contrast to the very first question, is going to give me a carboxylic acid. So none of the carbon bonds are changed in this reaction. I keep all of them as is, but in the location where it was a primary alcohol, that becomes a carboxylic acid. And it needs to go all the way to the carboxylic acid, not to the aldehyde. And again, I'm adding O's, more O's, removing H's, so this one is an oxidation reaction. All right, I'll be back with page 2.